Good morning everyone, my name is Siti Saenab and today I will be presenting a short micro-teaching session about the stoichiometry, the mole concept for senior high school students. But before we start, let's pray together according to our own beliefs. Pray begins. Pray ends. Before we begin, let's think about something. In science, every quantity has its own unit. For example, kilogram or gram for mass and second for time. And what's the unit of amount of substance? The international standards of units, we have the units for length, mass, time, and the others. And how about the amount of substance? It's called mole. And what is mole?
Well, that's exactly what we're going to find out today, because today we will dive into one of the most important concepts in stoichiometry, the mole concept.
As you can see on this slide, our basic competency cover applying the fundamental concept of relative molecular mass, chemical equations, the mole concept, and concentration levels to solve chemical calculation problems. Now, from all these topics, we have 4 competency achievement indicators, but today we're going to focus specifically on the mole concept, Avogadro's number, molar mass, and molar volume. So, let's get started. For the first, we'll learn about the mole concept and Avogadro's number. In daily life, we use special counting units to make counting easier, like 1 dozen means 12 items. In chemistry, 1 mole equals 6.02 times 10 to the power of 23 particles, and it's called Avogadro's number. And the number of particles can be atoms, such as carbon atoms, can be molecules like water molecules, and ions, hydrogen ions. Now, let's look at the relationship of the mole and the number of particles. Here's the magic triangle. This triangle helps you find any formula depending on what you're looking for. We have 3 variables here. The end of the top of the triangles is the number of particles, this one is the mole, and Na is Avogadro's number. The rule is simple. Cover what you want to find and the remaining tell you to the formula. For example, cover N and the formula will be mole times Avogadro numbers. And when we cover mole, the formula will be the number of particles divided by the Avogadro's number. Now, let's try it with the example on the slide. If there are 0.5 moles of hydrogen, how many hydrogen particles are there? We know that the mole is 0.5 moles, and the Avogadro's number is 6.02 times 10 to the power of 23, and the formula will be number of particles equals mole times Avogadro's number, and the result is 3.01 times 10 to the power 23 of hydrogen particles. Next, the molar mass. If 1 mole tells us the number of particles, now the molar mass will tell us the mass of 1 mole substance, and the unit is gram per mole. The molar mass can be relative atomic mass or AR and can be relative molecular mass or MR. For the relative atomic mass or AR can be identified from the periodic table of the elements. For example, the atomic carbon. 6 here is the atomic number and 12 is the relative atomic mass. And how about the relative molecular mass? This table will show us how to measure the molar mass from the different molecules. The idea is simple. Add up to the atomic mass of every atom in the molecule. For example, the carbon dioxide, AR of carbon is 12 and the oxygen is 16, and there are 2 atom oxygens, so the calculation is 12 plus 2 times 16, and the molar mass will be 44 gram per mole. And the relationship of mole and molar mass can be described by magic triangle with three variables: m for mass, and the unit is gram, and the number of moles, AR or MR, is the molar mass, the unit is gram per mole. For example, how many moles are in 88 grams of carbon dioxide, with the AR of carbon is 12 and oxygen is 16. So, how to answer? For the first, find the molar mass of carbon dioxide, and this calculation we can get 44 gram per mole. And the second, apply the formula. When we cover N, the formula will be mass divided by molar mass. So we put the value 88 gram divided by 44 gram per mole, and the mole is 2. Next, what if the substance is in gaseous form? Chemists also relate mole with gas volume. So let's talk about molar volume of gas. There are two conditions at STP and RTP, or standard temperature and pressure, and room temperature and pressure. For the STP condition, 1 mole of gas equals 22.4 liter per mole, and for the RTP condition, 1 mole of gas equals 24 liter per mole. On the left side, we have magic triangle describing the relationship of molar volume of gas with number of moles. The idea of the formulas is same with the previous slide. For example, how many moles are contained in 44.8 liter oxygen gas at standard room temperature and pressure? And how to answer it? For the first, we know that the volume is 44.8 liter, and the molar volume at standard temperature and pressure is 22.4 liter per mole. So when we cover the number of moles, we can get the formula is volume divided by the molar volume. So the N equals 2 moles. So those are the mole concept that we have learned today. And before I close the meeting, is there any questions? If there is no, here are the conclusions. Mole is the central concept in stoichiometry. 1 mole equals 6.02 times 10 to the power of 23 particles, and molar mass connects mole and mass, and molar volumes connects mole and gas volume. To sharpen your memory, here are a few exercises you can do at home. You can screenshot the questions in 3, 2, 1. Okay, that's all for today's lessons. I hope you found it helpful and easy to understand. And thank you for your attention. See you next time. Assalamualaikum warahmatullahi wabarakatuh.